I'd like to use this video to talk about a good practice for inserting a manufactured part from Parts for CAD. I'll be importing a Bimba cylinder assembly and going through the process of putting it together and doing some basic processes with it, and then putting it into an assembly. So let's get started. Selecting the Insert a Manufactured Part, you'll be taken to the Autodesk Fusion 360 Parts for CAD. You'll need to log in and also pick your nationality for a language. I already know my model number, but you can browse by alphabetical listing or simply by clicking on different ones, manufacturers. I'm going to go back to the very top and search for my model number in the search panel. It happens to be an MTCM Bimba cylinder. Once it finds it, I'll simply navigate to it, and I'm going to pick the first one on the list, a 25 bore by 20-inch stroke linear cylinder. Now, once you get logged in, you'll get the option to pick to Autodesk Fusion 360. Once you do this, you'll get this launch application, and go ahead, you can check this so you won't have to see it every time. Open the link. You can close this window at that time and it'll show up in Fusion 360. So there's my model. I'm going to just accept where it's located and say OK. The next thing we want to do is prepare this assembly for use in other assemblies. You'll notice that it is a sub-assembly right now in an assembly. I don't want this. I want this to be the top level. We'll fix that in a second. But the first thing is you need to talk about constraining it or making a united group. Now, if you want the cylinder to act like a cylinder in motion back and forth, you must constrain it. We'll do that in a second. But if you just want it as a model, you can just simply pick on the top level, right click and make it a rigid group. This will bind it all together as just one big lump. None of the parts will fall off. It's just one big lump. If that's not what you want, then you don't want to use rigid group. Here's what I would do to make it flex. So what you want to do, I'm going to turn around a little bit so I can see it better. And I want to do as-built joints. The first one I'm going to do is between this rod and this plate. And it's going to be a rigid joint between the rod and the plate. I need another one, so I'm going to do this one to the plate again. One more between this, the piston, and the plate. Now that's good enough for holding it together, but as you can see, the piston is not in position. So what I want to do is make a new as-built joint slider so it can act just like a cylinder. So I'll change the slider. The first component is the piston and the second component is the body. And say OK. Oh, didn't work. Let me try again. As-built joint, slider between the piston and the body. Now I was looking for a position for the constraint. I'll just put it on this front face and say OK. Now as you can see, I can move the piston. Well, not really, not yet, because what I need to do is ground the body. So I'm going to ground the body, and now you can see that I can move the piston. But it has no control. So what I want to do is put it back in position and edit that joint. Limits. I want the minimum and maximum. This is the 20 millimeter stroke cylinder. I'm in an inch assembly, so I've got to put minimum be 0, just put mm. I'm not going to change my units of the whole assembly. I'm just going to change the units of motion. And it's 20 millimeter mm. Now I'm not going to set a rest position. I'm going to say OK. And as you can see now, it moves 20 millimeters. Okay, now I'm ready to finalize my assembly. Okay, now to get this subassembly at the top level, I'm going to simply right click on it and save copy as. I'm going to put it in my demo models and call it a bimba cylinder. And it's a 20 millimeter by 25 millimeter by 20 millimeter stroke. Now, I'm finished with this. I'm not going to save it. I'm going to open up the other one to show you it's now its own assembly. So if I go to demos, I can see here that there's the bimba cylinder we just made. I can open it and you can see it's the top level. Now I want to give you a little tip on changing the color of a model and maintaining it in the next assembly. Here is my subassembly. Now you may want to color it or put different decals or whatever on it you want. You would like to maintain these, such as in this one I've colored the parts, as you can see. And I would like to maintain this as it goes into my, as a subassembly back into my main assembly. So if I go into a new assembly and I insert that one I had colored, just plain insert into current design, you're going to see some issues. I'll just accept where it's sitting. It's fine at this point, but it is a link component. You may not want it to be linked, and if you want to break that link, watch what happens. You lose all the colorization. This is not desired. There is a better method. So let's get rid of this subassembly and do it with a method that's going to maintain the colors. So if I go to insert, insert derived, and then I can go to the same assembly and open it. Now once you're in that assembly, you want to select the top level assembly from the browser. This gets all the features below it. And say OK. It comes into your existing design and you notice it's still linked. So I'm going to break the link again, but it maintains its colorization. So this is a better method of doing it. One last point about the insertion of this subassembly. You notice it's not grounded. Now you want to be careful and not ground the whole cylinder. You want to just ground the body. If you ground the body, you then still flex it, as you can see, and the cylinder is grounded. Or if you don't want to ground it, you can constrain it with joints. Thank you for watching.